Hello and welcome, Mindsetters. This is Learn Extra Live Grade 11 Maths, and this is Dina. How are you,
Grade
Dina?
12,
Great, I'm still stuck in the past. Grade 12 Mathematics. It is your turn, Grade 12. How are you, Dina?
I'm very well and ready for the next batch of grade 12 lessons.
Awesome. Let us know what we'll be doing today.
Everybody, we'll be looking at some analytical geometry as well as some trigonometry. I know that prelims are up, so we're trying to condense two little topics in the hour.
Time.
So let's see how it goes.
Awesome. Thank you, Dina. You can go over to the board and prepare your lesson while I let you guys know about our awesome prizes today. You do know that the prizes are the calculator. Now, there's the Casio calculator and the labeler. I know you guys are loving this labeler and calculator. So make sure that you are today's winner. Make me aware that you are on the page and you know by now that it's facebook.com/learnextra and our Twitter handle is @learnextra. Guys, today's going to be awesome. You heard we're doing analytical and we're doing trigonometry. So you've got to keep your focus because it is going to be fast-paced and really exhilarating. Thank you also to Liberty for such an awesome show. Thank you for bringing us this show. Over to you, Dina. Are you ready for us?
Thanks, Katlego. Let's start then with some interesting mathematics that will keep you going for the next little while. And I thought we would post a challenge question first, so that those of you who kind of accelerated and in front of us here in the studio can get on with some really challenging mathematics. So let's have a look at the question. The challenge question is to determine the general solution of cos 2x equals 1 minus 3 cos x. That's worth about 7 marks in an examination. See how you do. Post your answers to Katlego and see which one gets that answer first. Right, while you're doing that, the rest of you who would like to see some tips on how to solve a general solution, let's have a look at the board. Right, we're going to do some trigonometry around the general equation as well. And let's have a look at an example that will take us through some of the key steps when finding the general solution. The equation that I've got here on the board is determine the general solution. And let's have a look at the meaning of that word general solution. It implies that you would like to find all the possible solutions that trig equation would have. So we're looking at the equation 6 cos x minus 5 equals 4 over cos x. So we are not going to be restricted to finding one value. We would like to look at all the values that equation might have. Now, this actually comes from the national paper from last year. And I did mark this question and found that many students did the following. They found that we have a cos x on the right-hand side. So they multiplied across by the cos x to get 6 cos squared x minus 5 equals 4. Okay, and there were many students out there who did that. So I want to alert you to some of the key areas that you need to focus when solving a trig equation. Firstly, there's a lot of algebra going on, so it's not really the trig here that's the problem, it's really the algebra. We've got some fractions hovering around, and we are definitely going to look at how to eliminate that cos x. But in order for you to not make this error, because the yellow is definitely an error, is to say I need to multiply both left and right by the cos x. So don't be tempted just to say I'm multiplying across, and because you're multiplying across, you're forgetting that the across means both terms, and so you're leaving this 5 to be not multiplied by the cos x as well. So when multiplying both sides by cos x, actually make yourself write that step so you don't land up just visually making the incorrect error, because then you would actually have two terms that you're working with. Had you done that, or had the students from last year done that, they wouldn't have landed up, so many of them, in this predicament of this yellow equation. So they just get rid of this error, and let's take the page a little bit down. And let's just take it a bit down. There we go. Oopsie, too much. There we go. Right, so having addressed what's happening with the denominator, if we now multiply through by cos, we get 6 cos squared x, and the 5 also has to be multiplied by the cos x. And if we multiply on this side by cos x, we get it equal to 4. So we've got an equation now that contains a squared term, a 5 cos x term, and a minus 4 equals 0. At this stage, we haven't really dealt with any trig. We've just purely been doing algebra, and the algebra happens to contain some trig terms. So let's see what the trinomial looks like. It's got a 6 cos squared x minus a 5 cos minus 4. How would we solve for this equation? Or how do we solve any quadratic equation? Because that's the nature of this equation, is to try and factorize it. And should it not factorize, we would then use the formula. And we've got, let's see if this will work, 3 cos x and 2 cos x. And we would like factors of 4 that when added give me 5. So I think if I take a 3 and a 4, and I take a 1 here, then I'm left with an 8 and a 3. So this looks like it will work. So we have negative 8 plus the 3 give us the negative 5. So these are certainly the factors. And grade 12s, please don't get stranded with this quadratic. If this quadratic doesn't have factors, then what are you going to use? Well, your quadratic formula is on your formula sheet, so use it and get those solutions if you're struggling to factorize. Right, from there onwards, we can now keep going. Again, we still have some algebra, a quadratic equation that we can factorize, and we now solve for each of the brackets. So 3 cos x minus 4 equals 0, or 2 cos x plus 1 equals 0. So we've got a cos x equals 4/3. And what can you tell me as you arrive at this cos x equals 4/3? What do we know about the nature of cos x? Is that those values do not go above or below -1. They are sandwiched between -1 and 1. So its maximum is 1, its minimum is -1, which is telling us that when you are wanting to find an angle that gives me 1 1/3, that's not possible. Okay? So therefore, I can't find answers here because cos x is sitting between 1 and -1. So in that instance, we're going to get no solution from here because it doesn't fall into the domain, or actually into the range of the cos x values. So we can't find an x here. What about on the side? How would we solve for 2 cos x plus 1 equals 0? Well, to solve for cos x is the first thing we want to do. So that's equal to -1/2. And we now have this new equation, cos x equals -1/2. And how do we solve for x at this stage is we would use our calculator. So we would have the -1/2 in the calculator, and we would ask for which angle gives me -0.5. And the calculator will give you one angle. It will give you an obtuse angle. But the ratio for cos to be negative could also have an angle that is positive or -120, and it can be written in multiples of k360, remembering that k is an integer. So your general solution is telling you that x can be 120 degrees as a unit, but then it could also be 360 degrees later. It could be -120 and 360 degrees later. So this solution here is what we call the general solution because it captures every single value that gives us a cos x equals -1/2. So it's a general formula for it. If you wanted specific answers, you would then look at the domain and extract those that would match that particular domain that you've been given. The other important thing is to remember that this k has to be 1, 2, 3, or -1, -2, -3. They can't be fractions. So you have to always remember to give the nature of k in your answer. Right, so that's a little bit on the general solution, and I'm hoping that some of you have now posted some answers to the challenge question because it follows a similar sort of route. But when it comes to the general solution, the equations are extremely varied. They can look very different, and there are slightly different approaches depending on what type of equation you'll have. So let us look at a slightly different question. Remember, trig is a good bulk of about 20 marks in your final exam, and 6 or 7, maximum 8 to 10, you could find in a general solution situation. The other 6 to 10 marks you could find in that section where you are working with reduction formulae and identities and all those various reduction formulae that you find. You will find some of those formulae in your formula sheet, but let's have a look at an example that was also very interesting because people approach it differently depending on what they focus on. So let's have a look at a question and see what you would focus on in terms of trying to prove a particular identity. Right, we'd like to look at this question also from an examination paper, and it's as follows. We would like to show that this whole fraction here could be written simply as root 6 minus root 2 over 2. And as an exam technique, always don't be thrown by the extensiveness or the magnitude of that particular question, because sometimes you can do one or two things and you tweak it down to something very simple very quickly. So even though it seems to be quite a big fraction, don't be daunted by it, number one. Number two, let's have a look at what it says. It says 4 times sine times cos 2a times sine 15. So the first focal point that you should be looking at is something special about the product of sine and cos. There's something about that product that immediately alerts you to the fact I know something that I can change when it comes to the product of sine and cos. That is at the forefront of the knowledge around trigonometry. So if we look at our little rule, the product of sine and cos says to us that if I have twice the product of sine A cos A, that can be simply written as the sine of one angle. So the product of sine and cos can be rewritten. Now if I have just sine A times cos A, then I'm really just taking half of it because I've got the double missing. So that is the same as writing sine 2a, but it's half of it. So it would be that. So very powerful identity to be able to write the product of sine and cos as one trig ratio, because as you can see, I'm dealing with one ratio, not two, so things get simplified quite quickly. Right, so product of sine and cos alerts me to it. I see that I've got a cos 2a and I've got a sine 2a over here. I see that I've got a sine 15, which I'm going to just wait, and then I see that I've also got a tan 225. So remember earlier we said, what would we focus on? Well, we usually focus on numbers. If we can change numbers, we would look at the numbers. And the second thing we would focus on is what identities do I have that I could perhaps utilize to reduce my number of factors or my number of terms. So with the sine 2a, we've already written it up here, that it is equal to 2 sine A cos A. So I can see that these factors here would divide into those factors there. I'm going to hold on for this cos 2a. And do you know why I'm not going to do anything at this stage? Because cos 2a, unlike sine 2a, has actually got 3 versions of identities, of expressions that are equivalent. So I'm not too sure what the algebra is doing at the moment. So I will wait to make that decision once I have seen, once I've completed the division, how it's actually panning out. So let's go and have a look at where we stand. So we have the numbers that we can deal with. We can deal with sine 2a because we know it's the product. And then we're holding on to cos 2a for a little while, and we'll hold on to sine 15. So out of all those 6 things that we could be doing, you have to make choices as to which ones are the simpler ones to start off with and hold on to the ones you're not sure about, especially things like cos 2a, which could take you in 3 different directions and you're not entirely sure which one to pick. So we let it hang on, we delay that for just a little while, and let's see what happens. Right, so we've now got, if I write this as 4 times sine A times cos A. Remember, we want to just wait to see what cos 2A is doing, and we want to wait to see what happens to that. We then have the sine 2A, which we could write as 2 sine A cos A, and we're then multiplying this by this bracket. Tan 225 is just 1 minus 2 sine squared A. Okay, and that's all in the bracket. Now, as you're writing this, because that's bracketed and that's in a factor, you would say 1 minus 2 sine squared A. I also know that the moment I have terms with a 1 and a squared sign, somehow there's a relation. And you don't have to memorize these. These are actually on your formula sheet. So have a glance at your formula sheet to see, is this a particular identity? And in fact, it is. It's the identity, all this is the same as cos 2A. Now, you'll have noticed earlier I said cos 2A, let's just hang on to it for a little while. And all of a sudden, we actually find that cos 2A is actually sitting nicely in the denominator. So it's going to divide beautifully into that numerator. And we actually didn't have to do anything with cos 2A. So you see, it's important to identify the focus and then decide what is easier to actually work with. Instead of just jumping in and changing everything that you see, that's not really a logical way of going about it. That's quite haphazard. So do reason your arguments out rather than just jumping in. Okay, so we've now got that this 2 can go into this 4 twice. We've got sine A can go in there. We've got cos A can go in there. We've got cos 2A can go in there. And what are we left with? We're left with this 2 and we're left with the sine 15. So all this reduces to 2 sine 15. Now, out there, everybody watching, do you think that twice sine 15 is the same as, do you think that's the same as sine 30? Okay. I'm sure a whole lot of you are jumping up and down wherever you are and saying that cannot possibly be, because taking twice the ratio is never going to equal to twice the angle. We are so tempted, because we are so used to doing the distributive law in algebra, to distribute in a trigonometric sense. But the distributive law is, by definition, only useful when it is being utilized in an algebraic sense, multiplication over addition. Let's look at what's happening here. That's multiplication over nothing. There's no addition over here. So don't just label every single distribution that you see in mathematics, whether it be in logs, square roots, trigonometry, etc., because distribution only works in one case, and one case only, and that is when you've got multiplication over addition. So don't be tempted to do that. I've seen so many people do that, and they get themselves really stranded because they don't actually know that distribution is only over addition. Right, so let's look then at what we're going to do with the sine 15. So we've got twice, and I'm going to wait for that, because sine 15 is the same as sine of 45 minus 30. Okay, and now you've got a nice compound angle over here that you can just expand out. So we've got sine 45. Again, this is in your formula sheet, cos 30 minus cos 45 sine 30, and then we've got 2 into, what is sine of 45? It's root 2 over 2 times, that is root 3 over 2. So we get minus root 2 over 2, and sine 30 is just a half. So if we carry on with the arithmetic, we get 2 into root 6 over 2 minus root 2 over 4, and we simplify further. We get 2 goes in there, and we get root 6 over 2 minus root 2 over 2, which is the same as root 6 minus root 2 over 2. Can I just say one word about surds? If they've asked you in surd form, please don't use your calculator, because you're going to be penalized. This was in last year's paper, and not a very well answered paper, because people just went all over the place. So hopefully we've narrowed down some of those focus areas for you. Well, over to Katlego.
Thank you, Dina. Guys, let's take a very quick break. If you do have any questions, please post them to us because we are here to answer them. So make sure that during this break, you are scanning over what we've just done and asking anything that bugs you. I mean, anything. See you after the break.